welcome. I hope you enjoy this webinar.
Great, thank you. So, hi everyone. Could you please also confirm that you can hear me? Were they in the chat box? Okay, great. Let me just open the camera a little bit, and then I will shut it down. Okay, hello everyone. Since I'm using another tablet, I will turn off the camera later on. Okay, so welcome everyone to this course. My name is Hadi Harb. To this webinar. My name is Hadi Harb. So I'm based in Barcelona, Spain right now, and I will go through this webinar with you. I had the chance to see engineering from different perspectives, like as an engineer, as a scientist, as an entrepreneur, as a consultant, and as a lecturer currently at EIT, where I specialized originally in artificial intelligence and signal processing, and currently this is typically what I teach at EIT. So let's get directly into our topic today, which is Internet of Things, as you know. Okay, so we'll look into what is the IoT concept, the difference between IoT and IIoT, Internet of Things, and Industrial Internet of Things. In fact, there's a difference. Then what you would need to build an IoT solution. What are the building blocks for IoT? From these building blocks of IoT, we'll be mentioning two platforms that are really excellent platforms, that are Arduino and Raspberry Pi, and we'll comment on them, when to use each one of them. We'll pick up a case study, case I'm personally familiar with, and finally, conclusions and questions and answers. So we'll attempt to do all the questions by the end of this webinar. Now, first of all, the Internet of Things. The Internet of Things, as you probably have seen it, you know about it, it is allowing things to connect to the internet. Okay? And by things, we really mean anything to connect to the internet. Anything to connect to the internet. It could be a washing machine, it could be a microwave oven, it could be a thermostat. And once you have this connection to the internet, this means that as a human, you can communicate with that machine, with this thing, remotely, and this thing can give you the data it has, it can receive from you commands that you give, and it will include intelligence. Now, typically the things that we deal with, the things that are connected to the internet, are sensors that will allow us to sense variables, such as you are measuring temperature, and sitting anywhere around the world, you can open your smartphone and see what's the temperature, for example, in your house. So sensors. Sometimes they also have actuators, meaning you can act. So using my smartphone, I can see what's the temperature in my house, and eventually I can turn on or off the heater or the air conditioner remotely. So it allows us to do this type of remote control. Okay? So IoT is about mapping in reality the physical world, like sensors, actuators, etc., onto computers so that we can use computers to access them, to control them, and get data from them. Now, why this Internet of Things became a reality today? In fact, it's because it is very easy right now. It's very easy to see to add a microprocessor, meaning to add computation to anything. Adding a microprocessor or a microcontroller, and we'll see examples in a moment how much really it costs. A few dollars, US dollars, you can add, like $2, you can add intelligence to a device. So it's the cost. The cost is very, very low. Hence, whenever we have an application where we think that by adding intelligence and by adding the access, remote access to a certain device or a certain thing, we can do it, and the cost is not big enough. It's really small, so you can actually create those systems quite easily, and it will be just a small addition to the cost of the object itself. So when we say an IoT device, Internet of Things device, it's a device that can connect to the internet. In reality, it will connect to a network, local network, and then from this local network, it will connect to the internet. For example, if you have a thermostat in your house, the thermostat, let's say it's an IoT device. The thermostat will probably connect to your Wi-Fi access point. So you have your thermostat here. It connects to the access point, the Wi-Fi access point. So we will be using Wi-Fi. Now, from the access point, you have access to the internet. And now, if you are sitting somewhere here on a smartphone, you will be able to communicate with this IoT device. Okay, so IoT devices, they have this access. They can exchange data with other IoT devices. The thermostat, for example, can communicate with another IoT device like a heater or an air conditioner, and it can send a command to it or receive some data from it. So they can exchange data with other devices, they can collect data from other devices, they can do computations locally, but in reality, what the IoT system would be about is that those sensors will be sending their data to some centralized server, to some computer, and some back-end applications. And those back-end applications and computers are the ones that will be doing the final decision. So they will be processing the data received from those sensors, making the decisions, and those decisions will be based on time, will be based on space, where I have a certain temperature, and hopefully these will be like smart decisions. We'll be adding intelligence in this case to a process that we are dealing with. For example, if I have an IoT device that is my thermostat, it can connect to the internet. This thermostat can decide also to start or stop the heater. The thermostat, since it connects to the internet, it can communicate with some weather prediction service online. Given the weather prediction service data, it will know, for example, like tomorrow, early in the morning, it will be -5 degrees Celsius. So it will start the heater probably earlier than usual. So this is the kind of things that you would expect from an IoT device within an IoT system. It's the ability to uh, communicate with other services and make smarter decisions. Okay, the example here of a thermostat that decides to start the heater earlier, depending on what are the predictions of temperature outside, is like a typical example. Okay, so we use the IoT, Internet of Things, devices, we build a system around them in order to monitor, to track things. For example, one of the applications would be if you have certain vehicles in your organization, you want to track them, you want to know where they are, or tracking objects. Like with simple tags now that you add on an object, you can track your objects remotely. Okay, you can track your luggage when you travel. So we track these things because we know how to map them, how to identify where they are. They can connect to a network, and from there to the network, to the internet, and we'll see where they are. So we can do things like automation. We can improve the efficiency of whatever process that we are dealing with. Let me give you an example of a process where we might improve the efficiency. It's a real project, personally, currently I'm engaged with. The idea is they have a building here. So in this building, there are different offices. So it's an office building. Now, for every office, you have a thermostat, thermo. So you have multiple thermostats. Every point I'm adding here is a thermostat in an office. Okay? The occupants of that office, they decide the set point of temperature they want. They decide what kind of temperature set point, SP, they want. This is the target. This is what you put usually on your thermostat as a target temperature that you want to have in this room. Now, clearly the occupants of a room will select the set point that is preferable to them. Set points, meaning the target temperature in an office, will depend on things like the humidity in that office. It will depend on the time of day. It will depend on things like whether we are in the winter, is it in summer. So it depends on factors. It's not always like 21 degrees Celsius that people would want the temperature in that office. So now in IoT, all those thermostats are IoT devices, so they can connect to the internet. We get the data from all those IoT devices onto a server. And we are recording all this data. So this data now is for more than a year, where you have the set points provided by people within every office, along with some other data, because the thermostat is measuring also humidity, and we know what is the time of date. Each time there's a set point, it changes. We know also the schedule. So is the day a holiday? Is it a working day, etc., etc. So you have all this information. Now you build a machine learning system. And what is a machine learning system? It's a system that will learn to predict. You give it data and you ask it to make predictions. This machine learning system will learn to predict the set points that are used by people in every office. So by utilizing all this data that is coming from those IoT devices, meaning the set points, the humidity at every time instant, and you have other data that you can get that are what is the weather at every time instant, because all of this is something that you can access. You combine them all together in order to predict what is the set point people would desire given the temperature outside, given the time of day, given the weather outside, and given whether it's winter or summer or what's the month in general. Okay. Now this is very useful because it will allow us later on to design better controllers that will control the temperature in different offices. It's like you get into the office, the controller already knows what you will be setting as a set point. So it will be prepared for you. All the occupants will get into the office, everything is prepared. When they get out of the office, the controller is also prepared. It will know, for example, when people are no longer in the office, we have to shut down or reduce the heat or reduce the air conditioning. So this leads to efficiency, this leads to automation, and this leads to this kind of intelligence that we would have, like I get into a room, I feel it's like at the perfect temperature. It's because a system was trained to predict what I'm going to use as a set point when I enter into that room. So this is one example of usage of IoT. To be able to build this, you need those IoT devices that are the thermostats that are measuring temperature and humidity. So they have sensors and they can communicate and transmit the data they have to a certain centralized server. And on this centralized server, all the analysis will take place. Now, if you look overall at an architecture, a typical architecture of an IoT solution or IoT system. On the bottom here, we have the physical world. The physical world is when you have things like the sensors or the actuators. So I have a temperature sensor, I have a temperature controller. Temperature controller is the type of device that will start or stop a heater, for example. Because how do you start or stop a heater? You need some kind of switch that will turn it on, turn it off. Or it could be more advanced, like regulating the flow of fuel eventually in a larger setting. Like you are using a heater It consumes fuel, it consumes gas. So you regulate the amount of gas or fuel depending on the requirements. Or it could be as simple as just turn on or turn off a heater or an air conditioner or something like this. So I have a temperature sensor, I have a temperature controller. The controller is acting on the field. So I'm putting here an arrow towards the field. The sensor is getting data from the field. And then you have some other things like eventually body temperature sensor. You can have things like light sensors. Okay. Any other things that you can add in the field, it could be occupancy sensors. For example, you can put sensors to detect if someone is in the room. You can use infrared sensors that will allow you to do so, to know if someone enters. You can so gets into the room or out of the room, so you can start counting how many people you have in the room. So these are the kinds of sensors we can add quite easily in our applications. So this is the perception layer. Perception layer is perceiving the environment and acting on it. This whole thing is our system that we'll call here a machine-to-machine gateway. It's the gateway between the perception layer and what you see in here, the applications, where we have the actual applications, like on a smartphone, on a computer, on a tablet. Now, between them, we have other detailed layers, like here we have a proxy layer. It's where the proxy manager, it's just like on a controller, you would have to connect things. So on the controller, you connect a sensor as an input, you connect an actuator as an output. While here on the proxy layer, it's something very similar. My proxy in is when I'm connecting a sensor into that system. My proxy out is when I'm connecting something out of that system. And between here, I have pre-processing or processing and storage layer, because all of the data that those sensors will be generating should be stored somewhere. So they'll be stored, they'll be processed. There's a search engine and other modules that will allow the applications to talk to those sensors. So between the applications and the sensors and actuators, there's a layer or multiple layers in reality, allowing the applications to discover. For example, if we plug in a new sensor, how on the application level we would know that there's a new sensor that's available. So discovery, communication, and all of this is via this gateway. Okay, so this is typically an IoT architecture. Now the communication between the perception layer, so if I clean all of this here, between the perception layer and the proxy layer in IoT is generally wireless. In general, we don't have wires that would connect them. In general, we don't have wires that would connect them. We just use things like Wi-Fi, like Bluetooth. Probably you are familiar with this symbol here. Bluetooth, Wi-Fi, okay? These are very, very common to allow sensors and actuators to communicate with some gateway. The gateway has now the connectivity to the internet. And this is where we can give access to all these sensors remotely. Here's another architecture, but now by taking specifically a vendor that you might want to use or might want to check. For example, if you are building an IoT application. Here's an example. It's from Microsoft. You have other vendors of IoT solutions. So on this architecture, you are seeing probably the same things that you will see that you saw before. Devices. We have here our devices. These are the field devices. They act in real time. Here, this is called RTOS. It's real-time operating system. So it's all real time. They will connect through what's called an IoT edge. This is the kind of gateway that's close to those devices. And after that, you have here data processing, and here are the different paths to connect the gateway to this upper application layer. Now, here in Microsoft, they define things like what's called a hot path, a warm path, or a cold path, depending on how much real time you want these applications. But again, the concept is the same. On one side, I have a perception layer. These are the physical devices in the field. On the other side, I have a An application layer, these are the typical applications that will run on a smartphone or a computer or so. Okay? And in between, you need the gateway. Now, to build an IoT system, what do you need? You need those sensors and devices that are in the field, right? You need the perception layer. And these are the ones that will be collecting the data. Like I'm measuring temperature, they will be collecting the temperature. I'm measuring uh, humidity. I want to act. So this is what first thing that we need. These devices should be smart. Smart meaning they have some microprocessor in them. They can do computation, including being able to connect to a network. We need the connectivity. Without the networking, we don't have IoT. We need the connectivity. So the data that is on a sensor could be transmitted to some other device, like a gateway. Because otherwise, all the data that you have on a sensor will remain on the sensor. So a human should go to that sensor, open it up, or plug it into a computer to see what's in there. This is not IoT. IoT, it's all transmitted over a network. So we need this connectivity. And there are different options on how you connect those sensors to the gateways, and then from the gateways to some other server or the cloud, what's called the cloud, and then now your data is available on the internet. You need also data processing. The example I mentioned with the data that you get as the set points decided by people in different rooms, and you are collecting all this data over more than a year, well, if the data is sitting there on a server and no one is using it, and we are not processing it to make predictions later on, it's kind of useless. So why do I need Internet of Things in this case? It has a meaning when we make decisions based on it, including, for example, making predictions, meaning building things like machine learning. So making predictions to predict what will be the desired temperature of someone when they get into a certain room at a certain moment in a certain day, according to ambient temperatures, or the weather outside. So you need this data processing so that you can make later on decisions. And almost always we have some user interface. So there's a user who will be interacting with those devices, those systems. There are a lot of things that will be done automatically, but there will be a user somewhere tracking and communicating with devices in the field. So this is IoT, Internet of Things. Many applications, consumer level, in business. So you have IoT. It's already clearly a reality. And most probably you are using already some IoT devices. Now, what about IIoT, which is Industrial Internet of Things? Now, if IoT was about making sensors and actuators accessible over a network and consequently on the internet, well, in the industry, we didn't wait for IoT to have this. Having sensors and actuators connected to controllers and available on a network, this was available a long time ago in the industrial applications or in industrial settings. So in this case, what does IIoT mean? Because the connectivity was already there. It is kind of pushing the limits a little bit further. So having access to probably every type of sensor that you have in a factory or in a plant, and every actuator that you have, your controllers are going to make decisions to control those actuators depending on data they receive from sensors, and also having all the reportings that you need, because if you are in a manufacturing facility or you have a processing plant, you need to get reports, you need to know what's happening, you need to get information about performance. So all of this is something that you need, so from a user level. So it's pushing things further to allow all of this to be digitized, computer-based and digitized. So to some extent, we can say that IoT is pushing a little bit further what we already have in industrial settings, meaning sensors, actuators, and controllers that are already digital. so that all the data will be accessible now on our network, and beyond that, creating reports, doing optimization, making predictions based on the data that we get from those sensors. Okay? Now, I'm mentioning a lot the concept of actuators, sensors, and controllers, in fact, because it is essential in industrial applications. It's essential when you do automation. So what do you need when you do automation? You have a sensor here. Your sensor will give data to a controller. The controller would decide by sending a signal to some actuator, and the actuator will affect your process, whatever the process is. P, I'm going to call it P. And then it's like a cycle. Typically, it's a feedback cycle. Okay, so my sensor might be measuring temperature. My actuator is a heater, so I start or stop the heater, and the process is the room that I am in. Okay, so my controller is always going to compare the current temperature that we have. Eventually, we'll be comparing it to a set point to make a decision and send it to an actuator. This is a very, very typical architecture that you have when you are automating something. Okay, so sensors, actuators, controllers are everywhere in industrial applications. So the connection here between the sensors, the controllers, and actuators is typically digital, so it's over a network. The same that we've mentioned in IoT, Internet of Things. This is what we are trying to do in IoT, okay, but more for business applications and consumer applications. In the industrial Internet of Things, it's in the industrial setting. So this IoT concept is often linked to what's called the Industry 4.0 concept. Now, what's this Industry 4.0? It's like the latest version or revolution in the industry. Now, if you start with the first industrial revolution, it's the revolution where steam power started to be used. It's moving from the use of human power and animal power only into the introduction of steam power. And this made a lot of change. So here in the late 1700, early 1800. Then you had Industry 2.0. Industry 2.0 was with the introduction of electricity. Electricity made a lot of change. In steam, in order to use steam power, if you are only relying on steam, you need to be close to the source of power. So if you want to turn on a machine in the steam power era, the steam generation should be really close to you. With electricity, no longer I have to be close to the power source. Electricity could be produced in some region and it could be distributed almost everywhere. So I can now run a machine without having to run the complete steam engine that is complicated to use. So it's like with electricity, you would use steam in general to produce electricity, but you would use it in centralized areas and then send this electricity to everywhere. And it made a lot of difference. It made things much faster, much easier to work with. You just plug in your machine into the electrical network, and now you have power. Before that, you needed the whole thing, the whole steam engine. This is Industry 2.0. Industry 3.0 started with the introduction of microprocessors, late 60s, early 70s, meaning computers. Microprocessors meaning computers. And this is what, in the majority of cases, we have right now. The majority of people are using computers to do control and automation. Industry 4.0 is the introduction of what's called cyber physical systems, meaning mapping now really every sensor, every actuator that you have, every controller. It's available on a network. You can access it locally from this network. You use the data, you analyze this data, you make predictions, and overall, you digitize the whole plant. Digitize the plant, the factory, the plant. You are digitizing it. Okay? So Industry 4.0 or IoT, it's related to the digital factory or digital plant. For example, if we are producing whatever products, like we produce cheese, we produce cars, whatever we produce, In the Industry 3.0, if we needed to know what was our performance yesterday, we would have to meet to do a meeting, and within this meeting, different people will be sharing reports that will probably they printed, and we'll discuss the uh, performance that we had yesterday, and then we'll set the plan for today, and now we start producing. This is like the typical way in a normal factory where you use paper. Okay, so I have to print some reports, discuss them, do meetings, start the schedule today based upon the decision. In a digital plant, you don't need all of this. Your performance, the performance of the plant or of the shift that you had, will be available to you as soon as you finish, and it's in digital form. The next day, when we produce what we should be producing, what's the schedule, it will be already on our computers. It will be already loaded there. We don't have to do a meeting to discuss what should we be producing today to produce it. It's already there. So this is Industry 4.0 digitization. So it needs all the digitization down to the sensor and clearly up to your computers that you'll be using. So IoT concentrates more on this data analysis part and applies things like artificial intelligence and machine learning. And by the way, what's machine learning is just a subset of artificial intelligence, where you train a system to predict something, to predict a value to you. Okay, you have machine-to-machine communication. You have also what's called big data. Again, what's this big data? It's simply analyzing data when you have a lot of data. It's like a threshold or a definition, if you want. It's when you want to analyze data that cannot be stored on a single computer. So if I want to analyze my data, it's not available on just my computer because it's too big to be analyzed on just my computer. So we call this big data. Now, why in IoT you would have big data? Just if you think about it, in a factory or plant, you have hundreds, you have thousands of sensors that are measuring things. I would have a vibration sensor here. I would have a temperature sensor there, a humidity sensor, a pressure sensor. There are really a lot of these. Every sensor is going to take a measurement, let's say every second, if we don't want to say more than a second. Now, within an hour, you have 3,600 samples, 3,600 measurements per sensor. Within a day, multiply this by 24 hours, okay? And then multiply the whole thing by 365 for a year. You will see that very fast, the data will explode. You will have a huge amount of data, okay? When you apply now machine learning and artificial intelligence tools on this data, the algorithms have the data, because to be able to benefit from machine learning and AI, you need data. You need a lot of data. Not the right type of data, but you need the data to be there. Okay, so this is where you see big data, AI, and machine learning are being very commonly used in IoT applications. Okay, so IoT applications are the types of applications where we rely heavily on the data that we are receiving from our sensors and actuators. Let me give you an example. What's called condition monitoring. Condition monitoring. In industrial applications, you have a lot, in many applications, you have a lot of machines that are rotating. You have electric motors and engines and generators. You have a lot of machines that rotate. Let's say that you have a lot of electric motors. On those electric motors, you can add vibration sensors. Very easy to add those vibration sensors. You capture those vibration sensors data. Now, electric motors will fail. There are always this possibility that electric motors can fail. There will be faults, in fact, that you can detect before a complete failure of the electric motor. Because a complete failure of a machine could be too costly for us, because it will break your schedule, break your production. So what people do, they do preventive maintenance. So every few hours, every few 100 hours or 1,000 hours, they will schedule maintenance and they will start checking on the pieces of equipment that they have. Now, if they do the maintenance too frequently, it's also costly because you are shutting down in order to do the maintenance. If they don't do it too frequently, the machine can fail without us knowing it. Again, it is costly. Ideally, repair something when you believe there's a problem without it being a complete failure. Okay, now condition monitoring will allow us to do just that. Will allow us to, by analyzing the data, to detect if there's something wrong with a certain motor. So if you have a lot of motors, it's very, very useful. And this is an application of IIoT. You get all of this data. In fact, it uses machine learning to predict when there's a fault or there's a type of failure and eventually a complete failure in the motor that will happen next. So this is condition monitoring. Now, in IIoT, the layers are kind of similar to IoT. We have the field level, we have the application level, and in between, the connectivity. The field level, same thing. You have sensors, you have actuators, and you have those devices that are where there's an embedded computer in them that are taking the measurements from the field or acting on the field. On the application level, this is where you have things like the predictions, like generating a signal to tell us that a specific motor is going to fail in the next few hours. And this will be informing maintenance people that this motor, so they need to schedule a maintenance operation on this particular motor. Okay, this is happening at the application level. And in between, you have the connectivity where you have a variety of choices in connectivity. And by the way, in IIoT, the sensors and actuators and the way they connect to a network is not necessarily wireless. In IoT, people think immediately wireless. IIoT, in the majority of cases, it's actually wired. People will plug in the sensors and actuators to a network, an existing infrastructure, because it exists in a factory or a plant. So in IoT, what are our components? We need the assets, intelligent assets, meaning they have a microprocessor in them. And when I say they have a microprocessor in them, they are computers. Small computers, but they are computers. So these are the ones that produce data. Measurements, typically sensors and actuators. You need the data infrastructure, as we saw with IoT before. You need to collect all this data, store it, and then you would have to do something with it. But first, you have to collect it and store it, like a database, some server. You need analytics. Analytics is actually making sense of the data. As I mentioned before, if you have all the data of the world and you're not making sense of it, it's not useful to you. It's actually useless unless we do analysis and we make decisions based on this data. And finally, you need the people. People like when I imagine you have a certain manager in an organization, and this manager needs some kind of dashboard to track and know what's happening in terms of performance, eventually make predictions. Well, you need the people at this level. Those are the people who will be looking at these kinds of things, like the dashboards. The dashboard is itself as a smart dashboard showing, like in real time, what's our performance and showing us predictions and allowing us to do simulations. What would happen if I did this or that? Well, this is done by, it's the result of the analytics that's applied on the data that's coming from those intelligent assets in an IIoT application. And the people here, if done correctly, they will be making the right decisions so that our organization will beat other organizations if they are not doing the same, because we'll be making better decisions. Okay, now let's get into the steps to build an IoT application. Not necessarily IIoT, Industrial Internet of Things, where, as I mentioned, typically what you are doing is the data analysis part. Let's say that you want to build an IoT application in general. You can use it in an industrial setting, and you can use it in a commercial, other business application, or personal setting. So what do you need? You need, as mentioned, you need the devices, the infrastructure for communication, and to build the actual applications. One option is to use existing devices, networks, and services. You can start searching for devices that are IoT ready, so they can connect to a network. You can rely on services like from people like Amazon, um, Microsoft. For example, here this is from Amazon, this is from Microsoft, Azure, or AWS, so Amazon Web Services. So these are, they created, so these companies and other companies, they created services around IoT. Okay, they will allow you to build this system. You connect those devices that you buy to these services, and now you have your IoT application ready to be built and then deployed. But you are relying heavily on platforms like Azure platform or AWS IoT from Amazon or any other company. Okay? Now, the types of technologies you might be seeing here, you might be using something like OPCUA. It's for communication. You might be, in terms of connectivity, what do you need to use in terms of connectivity? You'll see things like LoRaWAN, NB-IoT, LTE-M. All these technologies will allow you to connect the devices that are in the perception layer to the gateways. Those gateways are compatible or connectable to the platforms like Azure IoT or AWS IoT. So, but the connectivity at the lower level will be things like LoRaWAN, NB-IoT, and the like. Okay, from those existing devices that you can buy. Okay? Now, LoRa here stands for low power radio, and then you have these here, these connectivities. These are related to the cellular. These connectivities. These are related to the cellular network. For example, LTE-M is long-term evolution machine type communication. And by the way, this is where 5G cellular network is actually playing a role. Not everywhere yet, but it's playing a role already, and it will play more and more a role in machine-to-machine communication. Because in 5G cellular network, this is part of the standard and the technology. It's allowing machine-to-machine communication. So IoT and 5G cellular network, they go hand in hand. Okay. So here NB-IoT stands for narrowband Internet of Things. So these are the types of technologies that you will see. The other alternative or option is when you build your own thing, your own devices, your own networks, and your own service. Okay? You rely on what already exists. You rely on some microcontroller and microprocessor. You rely on things that are available to you. You can use LoRaWAN and the like, or LTE-M or 5G, or you can use also things like Ethernet, Wi-Fi, Zigbee, Bluetooth. And to build your services, you rely on the development of web services, normal web services that a lot of people are familiar with, and what's called here APIs, application programming interfaces, to allow a machine that connects to the internet to talk to a server that is available on the internet. So you can build your own system. Let us take a look now if you want to build your own system, because if you want to buy existing devices and networks and services, it depends really on the services that you want to use or the platform that you want to select. You have to learn it. You have to understand what they recommend or what they promote as an architecture. Like if you use Microsoft, you have to learn about Microsoft solutions. If you use Amazon, same thing. Okay, so let's concentrate now on building your own thing. So the building blocks, if you want to build your own application, is some kind of computer. Okay, so microcontroller and computer board, some kind of computer you need. You need the sensors if in your application there's a need to measure something. You need some actuators eventually if you want to act, to remotely control something, and web services. Now, web services, you can self-manage. It's very easy actually well, relatively easy depending on the experience that you have to get us a server that is running Windows or that's running Linux and build a web service there. You can build it. Okay, it will cost you probably starting from 30 US dollars per month, something like this. Okay, you build your service, and with some programming, you have your web service available, meaning the data that will be sent by your sensors and actuators would be stored on the server in a database, and once it's on the server, you can create interfaces to access this data from any smartphone, for example. Okay, or you can use existing solutions, what's called a cloud solution. Again, we'll mention like Amazon, because Amazon have cloud solutions, AWS, Amazon Web Services. Okay, they will allow you to do the same thing, this same type of web services, but without really having to manage your own hardware or your own server. Okay? This is what you need. Now, how much all of this would cost, or what kind of sensors, what kind of controllers we might have access to? Well, here's a sensor that you might use. It's a camera. It's actually a smart camera. It allows you to do object tracking, face recognition, line tracking, tag recognition. Like if you are reading a 2D tag or QR code, recognizing colors, object recognition. So imagine you want to build a device that is able to do this recognition, like some kind of smart device. How much does this thing cost? Approximately 55 US dollars. Where do you get it from? Well, here's a website, and you have a lot of other examples. I'm going to paste here a URL to this website. And all the other examples, we are going to see them. They are from the same website. Okay, there are other websites available. Okay, but here it's DF Robot. They have a lot of sensors, a lot of controllers that you can use. Okay, this simple camera, I can use it. Here's another example of a sensor. It's a pH sensor. Many applications you would need to measure pH of a solution. For those of you who are not familiar, it's like the acidity. You are measuring the acidity of a solution. In the case study I will mention in a moment, in fact, this is exactly what in the past we used to measure pH of a solution, and it was in cheese production, so in dairy production. We need to measure the pH, for example, to specify when do you cut a certain cheese or so. So how much does it cost? Probably somewhere around, like, it's 65 US dollars. Here, a microcontroller. Microcontroller is the building block that will connect to sensors and actuators and will do whatever you want. This thing here is a microcontroller, 6 centimeters, as you can see here. Very, very small. It's a board, a complete board, and it can connect to Wi-Fi. It can connect to Bluetooth. Okay, how much does it cost? $9. Other things that we can do. Well, a system that you put in the field, that you build your own, it will need eventually some display, right? Here's a display. Okay, you can add this display. It could be a color display. How much does it cost? $18. And some other things like a switch to allow an operator or a user in the field to make a selection. This is called a rotary switch. So the operator will be making a selection, like select a program to run or a product to produce. It will cost like $5. Okay, so these are the building blocks in hardware for a solution, a smart IoT or an IoT device. Now, in building IoT, you have to do programming. Now, what do you use as programming? Very common to use something that is called C or C++ to program. Now, you see it used in a platform that we'll mention just in a moment. It's called Arduino. Great platform. It's a microcontroller. Okay? C++. You might use Python. You might have heard of Python or used Python in the past. It's also very, very common. So if you want to learn some programming language, if you are not yet familiar with them, I recommend that you try C++ and Python, both, because they are very, very useful to build an IoT application. So now, Arduino. I mentioned Arduino. Here's Arduino. It's a microcontroller board, and you connect it to your computer. via USB, you program it, and then you connect it to several actuators and sensors, and it can do the control. The great thing about this board is that you can extend it so that it will connect to the internet via Wi-Fi, via Ethernet, so via wires or wireless. It can do Bluetooth connection, etc. So very, very powerful as a board. How do you program it? Here's how you program it. This is a code. You type in the code. You say, I'm going to push it or download it on my Arduino controller, so my controller, and now your controller is ready to run. I will show you in a moment a website of how we can play with this. And then we have something called Raspberry Pi. By the look of it, it seems like the Arduino. It's not really so different, but in reality, it's very different. The Raspberry Pi has the same size. By the way, both have the size of like a credit card, both. The Raspberry Pi is actually a computer. It's a complete computer. The Arduino is more of a controller. It takes sensors in and it provides signals to controllers, to actuators. The Raspberry Pi is a complete computer here. Okay, you connect it to to a keyboard, to a display. It's a computer, and you can run Linux on it. You can run Python on it. Okay. Now, when do you use Arduino? When do you use Raspberry Pi? Well, if your objective is to do control, pure control, like turn on a heater, turn it off, control a robot, and you connect it to a network and make it available remotely, use Arduino. If your objective is to do more computations, in this case, use Raspberry Pi. Computation, for example, something like machine vision or computer vision. You're creating a robot or a door. On the door, you want to add a camera, and this camera should recognize who's getting in. Use, in this case, a Raspberry Pi. So both can be used for IoT, and one of them more for control, the other more for computations. Now, an example of a case before we get into the tinkering, and this will be almost it for today. The case here, it's in the context of cheese production. So we wanted a kind of instrument that will allow the operator in the field to measure pH, to measure temperature, and by selecting the program, so whatever product they want to produce, for example, a certain type of cheese, there will be alarms from time to time telling the operator what they should do, okay? So an alarm will tell the operator, now you have to open this, now you have to do that, okay? And we wanted at the same time to access this remotely. So whenever we are around the world using a smartphone app, we wanted to see what is the pH, what's the temperature of every solution that we have. Well, what we did is build an Arduino-based system. So it was Arduino. We connected the pH meter, temperature sensor. The Arduino connected over Wi-Fi, and then it connected to a server, and from the server we had access remotely. Okay, the whole application, the whole thing, $100. Okay, so this is an example where you can build a complete system like with $100. It's an IoT application. Okay, so to just show you an example of how you can play around, for example, for Arduino with this solution, let me share rapidly the screen. I'll show it to you because you don't have necessarily to buy. By the way, how much does it cost, an Arduino or a Raspberry Pi? With $50 US, you can do it. Okay, but if you even don't want to do this, here's a website, excellent website. It's called Tinkercad. Let me paste here. Here. Okay, so this is an excellent website that will allow you to do simulations. Okay, including creating, so you can create projects. So here, Tinker, you can create circuits. I'm going to have I have a circuit here. Let me tinker with it. Okay, so here I can add devices. If you look on the right, you have something like Arduino. I can drag it and drop it in here. What's great is that very, very easy to use. You can select the components. So this is a board here, Arduino board, a controller. I'm taking an output from here. It goes through a resistor, then through an LED that will turn on, and then it goes to ground. This is it. The only thing I want to do is simply to flash. Okay, this LED to flash. A very simple application. Look at the code. Here's the code. It's in C++. I define pin number 2 to be an output. And if you look with what is pin number 2, here it is, pin number 2. I'm defining it as an output because I want the controller to send the signal out of this. And then loop, it will repeat this forever. Digital write to high, so turn on this output, wait for 500 milliseconds, turn it off, and wait. Okay? Very simple. Click on simulation, start simulation, and it starts, boom, flashing. Very simple. And you can do a lot more than this. Okay? So here I'm just showing you an example, but you can do a lot more. So if you don't want like to directly start with the hardware, to tinker with the hardware in order to build the application, you can just do the simulation and build a complete system. And once you're happy with it, you purchase the hardware. So now to summarize, and this will be almost it for today. To summarize, we saw today what is IoT, which is commercial applications, business applications, and allowing sensors and actuators to connect to the internet. Sorry here. And we saw what is IoT, which is typically in the industrial context, and it's mainly about data analysis. And we saw the options to build a system. Now, a word here about a graduate certificate of competency that exists at EIT that was developed. It's about IoT. For example, the concepts that we talked about today are covered in this graduate certificate of competency in IoT. Okay, so it's a program where we get into much more details about what we discussed in here, like 6 weeks for IoT platforms and methodologies, 6 weeks for network engineering for IoT, 6 weeks web languages, so programming, cloud services, and finally 6 weeks for IoT embedded systems, meaning like an Arduino and playing around and developing things around the Arduino. And this is it for today's webinar. Thank you.
Thank you so much, Dr. Hadi, for that informative presentation, especially from my end as a non-engineering professional. It was quite nice hearing exactly what IoT is and the different uses it has in our households, businesses, and the world as a whole. So right now, I'm just going to allow you to go through the information that was sent in the chat box. So please answer the questions that we might have there. I think we have about 4, if I'm not mistaken. They did come towards the end of the webinar for your reference. And then what I will be doing currently, I will be sharing the courses that we have at EIT that are related to IoT. So it is the graduate certificate in the Internet of Things that Dr. Hadi went through. We also do offer a professional certificate of competency in programmable logic controllers, PLC and SCADA systems, an advanced diploma in industrial data communication, networking, and IT, and then our bachelor's as well as master's in the same field, industrial automation. So all of these courses are available at EIT. I will be sharing our course schedule link as well as link to the website in case you guys would like to see the courses that we have on offer at the institution. Okay, so these are the upcoming courses that we currently have at the institution. As I've mentioned, I will also be sharing a link. I will leave it in the chat box so that you guys are able to go to the EIT website and see the various courses that we currently offer that will be running starting now, actually. I do see the upcoming dates are for the 2nd of April, so we have courses starting in April already. Okay, so we will have upcoming webinars. The ones that I'm seeing are all technical topics. They are available on the EIT website. The website link that I will be leaving in the chat box, you just go through and see the webinars that we have. If you're interested in any of the topics that are showing on the screen, please register for the webinar. We will be happy to have you once more. Okay, I think a lot of people have been asking about this. This is the certificate of attendance. So, ladies and gentlemen, if you could please just scan the QR code or follow the link that is up on your screen currently. This will allow you to fill in a Microsoft form. This is how you request for your certificate of attendance. So you have until Monday, the 11th of March, 2024, 5 a.m. UTC time. Unfortunately, no further request will be taken if you do not request for your certificate in time. So follow the link. I'm just going to quickly leave it in the chat box. The people who are able to scan, you can go ahead and scan. I will leave the I will leave the slide up so that you're able to scan. Just let me just go back to the last slide for the Q&A. Dr. Hadi, could you kindly just answer those questions, and then I will go back to the slide that has the scanner so that people are able to request for their certificates. I will also leave the link in the chat box.
Okay, great. Thank you. So we can look at the questions. I'm going through the chat box to see if we can. So the questions. Okay, yes, it could be applied. So IoT could be applied in any area. In fact, railway or wherever you want. Sadiq develop a sensor system that detect adulteration in milk. I invite you to check this DF robot to see what kind of sensors they have. They have a lot of sensors. Not sure exactly about what you are trying to do, but in this case, there might be a process, a complete process that you would have to apply, not necessarily a single sensor. Okay. For example, in milk, you have systems that will use light in order to detect, to measure things, to do measurements in milk. But I'm not sure that an existing sensor, you can just purchase it and use it as is. Okay, for data collection, in order to build a learned system, how do you ensure the data is valid? Okay, this is actually it's really an important question, because normally you don't know. Normally in machine learning, when you apply machine learning, you are going to assume that the data will be noisy. And the models that you create would suppose, or you would want them to deal with data even if it's noisy. But you cannot really ensure that the data is correct or valid. The thing is, when you collect a lot of data, outliers will be seen. And there are methods that will allow you to remove outliers that probably are the ones containing those the noise or the errors. Okay. Also, we have a question about how many layers. I would say here it's a kind of the main layers from my side are the perception layer, where you have the sensors and actuators, so the field. You have a layer that is more of the data analysis layer. In between, there's a gateway layer. And above the data analysis layer, you might have eventually some other business layers that will make decisions, but I would say 3 to 4 layers, okay? It's not as standardized as in industrial applications, because in the industry, you have standards actually. You have, for example, a standard that's called ISA 95 that standardizes the number of layers that you have in an industrial application. In IoT, it's kind of less standardized. Okay, when Industry 5.0 expected to be achieved? Well, it seems to be some people are starting to talk about Industry 5.0, but still, Industry 4.0 is not yet. Like, it's probably 90% of the organizations and industries around the world, they are not yet in Industry 4.0. They are kind of far from it. So if people are talking about Industry 5.0 today, it's still more of really futuristic because the grand majority of organizations are not yet in Industry 4.0. They still use paper. They are not in digital factory yet. Okay, other questions? I'm checking. Okay. Is there any prerequisite background or knowledge for IoT certificate course? Please check the website, EIT website. I don't think that there are high-level prerequisites for this course because it's a professional certificate, or if it's a graduate certificate. So please check the website because you have the details there. Okay, and otherwise you can contact a EIT and they will give you all the details about it. Okay, other. Okay, the alternative to Arduino, it's Raspberry Pi. Let me just type it in here. I'm going to type it in. In fact, basically, Google Raspberry Pi. You will see where you can get it from. Okay, so here it's raspberrypi.org. Here. Okay. Other questions? How might we make use of IoT for enhancing energy efficiency on autonomous units? Okay, an example is like the one that we've mentioned. Typically, one of the things is making predictions of what will be the targeted in heating, for example, what will be the targeted temperature that people would want. I would say it's mainly by analyzing data and trying to use predictions so that if you do control, you don't waste time. One of the problems when we do control is that we take the action and it's already late. Okay, so we'll spend more energy. So it's I would say it's a complete it's a problem on its own. Okay, and you have different options in it. Like if it's in a heating application or so, so energy efficiency. If it's in a heating application, I would say by relying heavily on predictions, predicting what's the target temperature, predicting what's the temperature outside the next few hours, and then designing a controller that is smart enough to take these into account. Okay. Future prospects to work effectively out in the field. Okay, what can be the main applications of IoT mineral processing plant? I would say there are a lot of applications, anything that's related to sensing, taking control, and reporting, and then analyzing the data that you have, you can apply it. Future prospects, it's data analysis. It's gathering more and more data and analyzing it. This is, in my opinion, the future prospects in IoT. And to work effectively on IoT in engineering, you need to know about programming and to some extent the technology of sensors. Okay, programming, networking, and to some extent the technology of sensors, how they are used. Are there any plans for Industry 5.0? I'm not aware of something that is really like practical and existing already. IoT applied to cybersecurity, like on top of my head, I do not see how to apply to cybersecurity unless it's clearly defined. What do you really want to achieve, and eventually with some sensor here or there, you might achieve it. But in cybersecurity, you rely heavily on analyzing the data that you get already from the network, what people are trying to do on the network eventually. Okay. Civil engineering field, absolutely, absolutely. Whenever you can put sensors and eventually do control and analyze data, you can apply IoT. Field necessary to work effectively on IoT, not necessarily electrical engineering, no. Well, as I mentioned, basically programming and some understanding of how the sensors work. Can IoT improve data science? I would say IoT is the source of data for data science, where you apply data science. It's not going to improve it. Okay, interesting. Can IoT be retrofitted into devices or machines that are not IoT ready? Yes, absolutely. In fact, by using a platform like Arduino or Raspberry Pi with the right sensors, you can connect it into an existing machine and you make it now IoT ready. Absolutely. Will data scientists and engineers be replaced by this automated system? A lot of the work will be replaced, yeah, but then we'll have other things to do. But a lot of work is actually could be replaced by autonomous systems and automated systems and artificial intelligence. Okay, compatibility between IoT devices and existing SCADA. Yeah, this will relate to software and the standards that are used, but it's a process. So it's a process, and you have organizations that kind of specialize into the mapping or allowing the compatibility of legacy devices with IoT systems. It will involve putting some gateways, some brokers that are called data brokers at some level. It will involve including these. Okay. It's free. Yes, Sadiq. Tinkercad is free for everyone. Is it possible to apply IoT on devices that doesn't inherently connect to a network? Now, the sense of it is actually when you connect to a network, when different devices communicate with each other, not necessarily available on the internet. Okay, you can do the whole application like in an industrial setting, and it doesn't have to connect to the internet. It could be local, but really it should be connected to some other devices. Difference between SCADA platform and IoT for monitoring power system. SCADA, let's say it's more professional and more industrial. IoT is open kind of to everyone, but ultimately you are achieving the same kind of functionalities between SCADA and IoT-based system. Biomedical, yes, you can apply to biomedical. Not sure if I have any information about like the economic and environmental costs of running data centers. I'm not familiar with what's the actual environmental cost of it. Besides, it's actually you need power and you need cooling. By the way, cooling requests a lot of power compared to the computing power itself. Is it worth to learn IoT if you're learning about repair, troubleshooting? It's really good to know because um, repairing, troubleshooting, networking might rely on IoT at some level in an application. Are industries waiting for technology to become more affordable? I would say industries wait because it takes time for them to change. You have a lot of legacy systems that exist, and in industry, it takes time. It's slow. So it's more like this. It's slow. Medical equipment, telecommunications. Okay, so all of these clearly you can apply them. Construction industry, I would say again, as I mentioned earlier, if you have any sensor that you can benefit from getting data from it, then you can use it, like sensing humidity, sensing temperature, measuring pressure in a certain structure, and getting all these data. It could be useful in this case. Is GSM technology also IoT? Now, it could be in areas where you don't have 4G, for example, or 5G, but most probably it's going to be replaced by 4G and 5G. Okay,
Okay,
investment.
my apologies, Doctor. I do believe we might just consider having a second session. I don't think you'll be able to finish these questions. They just keep coming and coming. And we have come to the end of our session. So I will be able to tell the team that you guys are still interested in this topic, and perhaps they can have the doctor run another session regarding IoT. I think you have about 50 more questions to go, and the time is not on our side. Okay, ladies and gentlemen, that concludes this part of the webinar. Thank you so much, Dr. Hadi. It was a really informative session. I do believe everyone is very happy with this particular topic and your presentation of it. I will be speaking to the EIT webinar team to see if we don't have an encore of this particular topic. However, thank you so much for your time and for the session. I hope you have a lovely day, sir. Everyone, the chat box will be open. I have included links on how to request for your certificate in the comment section, as well as information on how to request a call to speak to an EIT course advisor, as well as the course schedule. Thank you so much. I will leave the questions open until about 5 minutes after this time. Once more, Dr. Hadi, thank you so much.
Great. Thank you. Thank you. Thank you, everyone. Thanks. Bye-bye.